In this video, we're going to finish up our discussion of the electron and light based on the POGL that we've been working on in class. So, light has a dual nature. That dual nature is considered to be a wave and particle. All right, so there were two scientists who had differing ideas of what this energy was. And so when we look at this, one scientist believed that the energy produced by an electron is a particle. The other scientist, which just happened to be his son, said the energy produced is a wave. All right, so before we begin our discussion or go deeper into this discussion, you need to make sure you know the parts of a wave, and we're not going to go over all of them, just what we need for class. All right, so the highest part of a wave is referred to as a crest. The lowest part of the wave is referred to as the trough. And when we talk about wavelength, we're going to be looking at identical points on adjacent waves. So right here, we're looking at these identical points. And so when we go through this, we have a complete wavelength. We have a complete cycle between these 2 points, and that would be considered a wavelength. So now we're going to be looking at wavelength, frequency, and energy. In class, we discussed that wavelength and energy have an inverse relationship. So if it has a long wavelength, then the energy will be low. But if it has a short wavelength, the energy is going to be high. So what I'm going to add to this now is frequency. And first, let's discuss what frequency is in the unit. Frequency is going to be how many complete cycles occur within 1 second. So again, we're looking at cycles per second. And the unit for frequency is called hertz. So in this top wave, we have 4 complete cycles. If this is our starting point, we're going to go through 4 complete cycles. 1, 2, 3, 4. And again, you're looking at identical points on adjacent waves. In the second example, you have 8 complete cycles, starting here at number 1, at the beginning at 1, ending at number 8. So the frequency for this is 8 hertz. And so looking at this last example of a wave, we have started cycle number 1, and we have 16 complete cycles. So the frequency for this bottom wave is 16 hertz. So as we look at this, the wave at the bottom has a short wavelength. The waves at the top have a long wavelength. So what does that tell you about the relationship between wavelength and frequency? There's an inverse relationship between wavelength and frequency, but there's a direct relationship between frequency and energy. So please make sure you get that down in your notes, that wavelength and frequency, or wavelength and energy, they have inverse relationships, but the relationship between frequency and energy is a direct relationship. And so in this last slide, we're going to be looking at the electromagnetic spectrum, and then we'll look a little closer in the next video at the electromagnetic spectrum on your reference table. So as we take a look at this, you have radio waves that occur on the left side of the spectrum, and you have gamma ray radiation that occurs on the right side. And notice as you move from left to right, the wavelength gets shorter. So on the left side of this spectrum, we have long wavelength with low energy, and on the right side of the spectrum, we have short wavelength with high energy. So low frequency on the left side, high frequency on the right side. So let's remember that light has a dual nature. That dual nature is particle and wave. The particle is called a photon, and then with the waves, these waves correspond with different wavelengths. And at the range of different wavelengths, you have different types of radiation produced.